Videos, we're going to talk about factoring. And to do that, we need to have a little bit of background vocabulary. Every time we've ever multiplied anything before, like say 3 times 5 equals 15, that sentence has two parts to it. The factors are the two things that are being multiplied together, and the product is the result at the end. That's true even if those factors are a little bit more complicated. Like, let's say one of them is a binomial. Binomial means a sum of two terms. When we multiply those together, it's still called a product. Even though it looks like there's addition, 4x plus 8, it's also the sum of two things, of 4x plus and 8, but it's the product of 4 times x plus 2. When you have multiplied in the past, what we do is we take the product of two factors, like 3 times 5, and we write it as a single product, 15. Factoring is the process of going in the other direction. We take the single product, like 15, and we write it as the multiplication, the product of two factors. We write it as 3 times 5. Or we take 4x plus 8, and we write it as 4 times x plus 2. That is factoring. Where the skill comes in, sometimes it's a little bit of an art, is when we start seeing much more complicated products. Like in this case where the product is a trinomial. Figuring out what the multiplication is, what two things were multiplied together to make that product is tricky. And that is what we're going to talk about today. That's factoring. Okay, so first, we'll do the ones which are a little bit on the simpler side. So a very common type of product is when you just distribute. Like for this problem, 3 times 2x minus 7. To find the product, we distribute 3 times 2x to get 6x, and 3 times negative 7 to get negative 21. So again, this 6x minus 21, that is the product. And the 3 times 2x minus 7, we would call these the factors. Or 4x squared times 2x plus 5, we distribute. So right here we have the factors. And once we're done distributing them, we would have the product. 4x squared times 2x is 8x cubed. 4x squared times 5 is 20x squared. What you need to notice is that after we're done that multiplying,
Francisco, Sharon, if you're in the building, come to the main office. Francisco, Sharon, come to the main office.
the coefficient that was in front of the polynomial is now a common factor in all of the terms. So notice how the 3 that was here, we can see there's a 3 in the 6, there's a 3 in the negative 21. The 4x squared, we can see there's a 4 and an x squared in that term, and there's a 4 and an x squared in the last term. It's called a common factor. So what we're going to do when we have a longer polynomial and we didn't see the factors to begin with, and our job is to write the factors, we are going to figure out what that common factor is, that thing that must have been distributed, and we're just going to undistribute it. So we'll take a look at a couple of examples here. 18x minus 24. Our job is to identify the GCF there. Look into the 18x and the negative 24 and see what number, or x, is a GCF, is inside of both terms, and in this case it is a 6. So what we're going to do is take the 6 out of the 18x minus 24 by undistributing the 6. When we undistribute the 6 from 18x, we're left with 3x. When we undistribute the 6 from the negative 24, we're left with negative 4. And so the factors of 18x minus 24 are 6 times 3x minus 4. We can do that for longer polynomials also. There is a bit of a catch here, though. When we do the longer polynomials, first of all, identify the common factor from the coefficients. Inside 12, 8, and 4, you can take out a 4. But also notice that there is at least one x in every term also. So that x is a common factor too, so we are going to pull out one x. Had there been an extra x here, well, then there would have been at least two x's in every term, so we would have been able to pull out two x's into the GCF also. But in this case, there wasn't. When we undistribute both the 4 and the x from all three terms, we have to remember that there are going to be three terms in this second factor here. We factor out the 4x from 12x to the fifth. We're left with 3x to the fourth because we had 5 x's, but we took out one of them, and so we're left with 4. From the next term, we factor out a 4x from 8x cubed, and we're left with 2x squared. And when we take the 4x out of 4x, notice that that doesn't disappear. We still need to be left with a minus 1 there. So the number of terms is quite important. However many terms there were in the original product, when it was written to us just as a polynomial, 1, 2, 3, there have to be the same number of terms after we factor out a GCF, 1,